In this video, we are going to review how to find the zeros of a polynomial. So again, a quick reminder is 0 is the value of x that is going to make the polynomial function value equal to 0. We also call this sometimes the root, sometimes we call this an x-intercept. But we're looking for those x values that when plugged into the equation is going to make the whole thing equal 0. So, problem is, we can start off in standard form. This is a very difficult process. Standard form is not nice for finding zeros. So, our options are we can factor the polynomial, which we will talk about in another lesson. Okay, that's interesting. Okay, or other option is we can graph it. Now, graphing is generally pretty easy when we do one of these. When you're looking at graphing, basically we're looking for where does the value function equal 0. That's where it crosses the x-axis. That's why we're calling it an x-intercept. So we just look and see where are these points where it crosses the x-axis, and those are our zeros. The one that we got to work at a little bit is factored form. Factored form is actually pretty easy to find the zeros. We just have to work at this a little bit. The idea with this is, again, we're looking for what values of x will make this whole thing equal 0. And we're using the fact that any number times 0 is going to equal 0. So if I can come along and I can make one of these, if I can make that 0, then it's 0 times whatever is going to be 0. If I can make this 0, it's 0 times whatever equals 0. The whole idea with this is I just look at each one of the factors and I said, what will make that factor equal 0? That's going to make the whole thing equal to 0. The other thing before we get into finding these, I'm going to just kind of a double check that often helps us is number of zeros. Oops, I'm on my disappearing pen. Let's take that off. Number of zeros equals the degree. Now, the problems we're working on, this will be true. We will look at some other things, that some cases where it might not be true. We're not going to worry about that right now. So a rule of thumb is we look at this, and I have x times x times x times x squared is 1, 2, 3, 4, 5 is x to the fifth. This is fifth degree. I expect 5 zeros. So that's just a good thing to look at before we get started with this. Now let's clear these out of the way. Always better to use sound effects, right? Okay. To find my zeros, as I said, I set the factors equal to 0. So here's one factor. Negative 3x equals 0. Here's a factor. X plus 1 equals 0. Here's a factor. 2x minus 3 equals 0. And here's a factor. X squared minus 25 equals 0. If any one of these is true, if any one of these situations, these factors equals 0, the whole thing will be 0. So I just solve all 4 of these, and some are easier than others to solve. We look at this one, we divide by negative 3, x equals 0. I take a look at this one, I subtract 1, x equals negative 1. Now I got to do a little bit more work. I'll add the 3. I get 2x equals 3. I divide by 2, and I get x equals 3 halves. This last one, I add 25. I get x squared equals 25. Almost out of room. I can do it. So x is going to equal, we got to take the square root of 25. But remember, when you undo a square with the square root, there's 2 possibilities. Other thing is, remember, we want 5 zeros. I got 1, 2, 3. I need 2 more. They're going to come from this second degree term is going to give me 2 zeros. So that's going to be plus or minus the square root of 25. So x equals 5 or x equals negative 5. So these are my 5 values. 1, 2, 3, 4, 5. That will make this whole function equal to 0. That's all there is to finding zeros if you are in factored form. We just set each factor equal to 0 and solve. Don't forget if we have a factor up front that's not in parentheses because we're not adding or subtracting. Don't forget if I have a squared in here, I'm going to have to do a little bit more to solve. Keep in mind this rule of thumb. Number of zeros is equal to the degree. Oh, wrong button. So let's give you a chance. I want this one. Try your hand at this. I got 3 here for you to do. Pause the video and see if you can find the zeros for each of these. When you're done, unpause the video and I will go through and work these out for you. We look at this one. 4. When does 4 equal 0? Never. X minus 3. That's going to be when x equals a positive 3. 5 minus x equals 0. We'll add x to both sides, and we'll get 5 equals x. So this is x equals 3, x equals 5. Second degree, 2 zeros. H, x equals 0 will work here. 2x minus 7 is going to give you x equals 3.5. 8 minus 2x is going to give you x equals 4. 16 minus x squared. Notice this is a squared, so again we're going to get 2 of them. We're going to get x equals 4 and x equals negative 4. Now notice on this one I have 2 zeros that are exactly at the same point. I don't see them by looking at here, but they're kind of hidden in there. That can happen, and if we're trying to account for all of my roots, I'm first, second, third, fifth degree, I need 5 roots. Last one. This is a second degree. So it's 2 of, basically, I could write this out as x times x minus 3 times x minus 3 times x minus 3 times x minus 3, x plus 1, x plus 1, x plus 1. There's 3 of these, 4 of these, and 2 of those. So I'm going to end up being 6 ninth degree. And you see if you write out all the factors, 1, 2, 3, 4, 5, 6, 7, 8, 9, you will get 9 of them. So you get x equals 0, x equals 0, x equals 3, x equals 3, x equals 3, x equals 3. Then you'll get x equals -1, x equals -1, x equals -1. This is that multiplicity we talked about, where something special is going to happen at the graph where you have more than one zero at the same point. Right now we're just finding all the zeros. I'll leave that for a different lesson.